So this example here leads us into the scalar or dot product of vectors. It's a really important thing to understand because the dot product allows us to find the angle between two vectors A and B. So you can see here in the pictures that we've got A and B and the angle in between them, theta. That angle is measured as being between 0 and pi because once the vector gets further than that, say B was to continue, we wouldn't measure the vector angle around that way anymore, we'd measure it that way. So that would be theta. So that's why we don't need to go beyond pi or 180 degrees for our angles. So the key result here with the dot product is expressed here. The dot product is given by the magnitude of A times the magnitude of B cos theta. So this is the thing I want you to remember to think about over and over in your head when we think about dot product. A dot B equals magnitude of A times magnitude of B cos theta. But the other important thing here is that if cos theta is perpendicular or 90 degrees, all right, we're going to get a interesting result for that, which I'll give you a bit of time to think about. And also if A or B is 0, then the dot product is 0. Now effectively if A or B was 0, you'd just have one vector there. So it's kind of pointless finding the angle between them. All right, so we're going to use this expression for A dot B. So we've got in the example 18, it says find A dot B given that the magnitude of A is 4, the magnitude of B is 5, and the angle between A and B is 30 degrees. So I'm going to write down my dot product formula. A dot B equals magnitude of A, and these are all vectors, times the magnitude of B, cosine theta. Here, the magnitude of A is 4, the magnitude of B is 5, and we've got cosine of theta. Now theta is 30 degrees. I'm actually going to write it as a radian, so pi on 6. And we know from our classic standard triangles that if we have pi on 3 and we have pi on 6, a half, root 3 on 2, 1, we know that cos of pi on 6 is root 3 on 2. So we'd have 4 times 5 times root 3 over 2, which is going to be 20 root 3 over 2, which would be 10 root 3. So that means for this first example here, the dot product of A dot B is going to be 10 root 3. Okay. So that's the dot product of A and B. In part B, again, we've got the same kind of vibe going on. All right, we're using, again, the same formula. This time we have 4 and 5 as our magnitudes of A and B as before, but we have theta equals 150 degrees. Now, if we think about that as a picture, I'm just going to draw roughly over here. 150 degrees would be over here. That's 150. Okay, and if we think about what 150 is, it's going to be 3 lots or 5 lots of 30 degrees, okay, which means that this angle here, the little angle, would be 30 degrees. So we could really think about this theta in terms of the 30 degrees here, okay. So in this case, though, it's going to be negative. So we've got the same thing happening, A dot B equals same magnitudes, so it would be 20, 4 times 5, times, and this time because it's a 30 degrees over this side, and it's negative, it's the same triangle but just flipped over, so it will be a negative root 3 over 2. So we know that that answer would be negative 10 root 3. So it's very important where the angles are in terms of how big those vectors A and B are. And as a diagram, and I'll just draw it on here, what we were really looking at, in particular for B, was a vector here, which was A, and a vector here, which was B. The angle between them is 150 degrees, and their dot product is given as negative 10 root 3. We'll do a bit more work on the dot product in the following example, actually discussing how to find this dot product part here.